Welcome back. So today I'm going to teach you how to solve cubic equations by factoring. But before we solve cubic equations, I want to review how to solve these quadratic equations I have up here on the board. So why don't you take a few minutes and see if you remember how to solve these equations. So you can pause the video and solve them, and then unpause it and see if you did them correctly. Alright, so let's look at A. We got 3x squared minus x minus 2 is equal to 0. So this is a quadratic equation. What do we have? We have a quadratic trinomial on the left side. So when we have a quadratic trinomial, we're always going to try to solve it by factoring first. Okay? So we want to know, does this factor? If it doesn't factor, then we're going to solve it by using the quadratic formula. So we're going to use slip and slide. So we're going to take this 3 and slip it to the back. Now we got 1x squared minus x minus 6. Because if you guys remember, when you slip the 3 to the back, you got to multiply those two numbers together. That's how we get the 6. So now I'm going to ask myself, are there two numbers that multiply together to be negative 6 and add to be my middle term? And my middle term is negative 1. Are there two numbers that multiply to be negative 6 and add to be negative 1? Yes. Negative 3 and positive 2. Now we're using slip and slide, so we're not done yet. We didn't factor it yet. So now we got to slide our 3 back into our answer. And then reduce our fractions. So 3 over 3 reduces down to 1. 2/3 can't be reduced, but remember we don't want to leave the fraction there. So now we have it factored. So what do you do once you get the equation factored? Well, now what we're going to do is we're going to set each of these factors equal to 0. So we're going to take x minus 1, set that equal to 0. Take 3x plus 2, set that equal to 0. So here we're going to add 1, we get x equals 1. So one of my roots to this quadratic equation is x equals 1. Now let's find the second root. So subtract 2, we get 3x equals negative 2, divide by 3. So the second root is x equals negative 2/3. So this quadratic equation had two roots. And that shouldn't be a surprise. The degree of this equation is 2. It's a quadratic. The degree of the equation tells you how many roots your equation has. Okay, so we're going to be solving cubic equations today. So we're going to be finding 3 roots. If we were to solve a 4th degree equation, we'll be finding 4 roots. Well, right on this screen, we're just solving quadratic equations. So all of these are going to have 2 roots, or 2 solutions. All right, so let's look at B. We got 4x squared minus 81 equals 0. We can solve this one 2 different ways. We can do it by factoring, because you should realize that this is one of those special cases. 4x squared minus 81, that's a difference of perfect squares. Because 4x squared is the same as the quantity 2x squared. 81 is 9 squared. So we could factor 4x squared minus 81 as the quantity 2x plus 9 times the quantity 2x minus 9. And set that equal to 0. And then, just like we did over here on this example A, once you got a factor, you set both of the factors equal to 0 and then solve. So when we solve this one, we get x equals negative 9 halves. When we solve this one, we get x equals positive 9 halves. So the roots are negative 9 halves and positive 9 halves. That's solving that one by factoring. But I could have solved B differently. I could have just did the square root method, which is a little shorter and easier. That's the way I would have done it if I had the choice. We had the choice. We didn't have to pick. I'm just showing you both ways. But the reason I can use the square root method is because we only have an x squared term. We don't have a linear term. We don't have an x term. So remember, what you do if you want to use the square root method is get your x squared term by itself. So what we could have done is we could have added 81 to both sides. Then we get 4x squared is equal to 81. And then divide both sides by 4. So x squared is equal to 81 over 4. And it's called the square root method because the last step of this process is to take the square root of both sides. The square root of x squared is just x. But whenever you do the square root method, you got to put plus and minus on your answer. So this will be plus or minus the square root of 81 over the square root of 4. So we get x equals positive or negative 9/2. And those are the two roots that we got when we solved it by factoring. Alright, so let's look at the last one. C here. See how we can solve C. Well, C is like A. It's a quadratic trinomial. So we're going to try to factor it first. So we're going to do a slip inside. So we're going to take this 5, slip it to the back, multiply by the 1, and we get 5. And now we got a leading coefficient of 1. So now I'm going to try to factor it. We'll put x and x out. Now I'm going to ask myself, what two numbers multiply to be 5 and add to be 2? Well, the only factors of 5 are -1 and -5, or 1 and +5. But if you take -1 plus -5, that's -6. If you take 1 plus 5, that's 6. What that means is we can't do this one by factoring. So we can't solve this one by factoring. So we have another method that we can use. And that method is the quadratic formula. Remember, we could have done the quadratic formula on A, because the quadratic formula always works. So if you recall, to use the quadratic formula, you got to get the quadratic equation in standard form, which it is. The quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we're going to identify our values of a, b, and c. Well, a is 5. B is -2, and C is 1. So we're going to plug these values in. So we get negative B. Well, another way to read that is the opposite of B. So in place of negative B, or the opposite of B, I'm going to put 2, because B is -2. So the opposite of that will be +2. Or you can think of it as having a double negative. Now I've got my b squared. Well, I'm going to take -2 and square it. -2 times -2, +4. Now I need to replace my a value. My a value is 5. And then we're going to replace the c value. And the c value is 1. And then we got a one more time. A down here on the bottom. Again, a was 5. So all we need to do now is simplify this. So we got 2 plus or minus under the radical. Remember, that's called the discriminant. We got 4 minus 20. 4 minus 20 is -16. And And then the bottom we got 10. So this is our answer. What can we tell about the answer? Well, the discriminant is negative. So since the discriminant is negative, that means it has two complex roots. That means the roots are imaginary. Okay? So what we got to do is we got to reduce our square root of negative 16. So I can make that the square root of negative 1 times the square root of 16. What's the square root of 16? 4. What's the square root of negative 1? I. So here's our roots. 2 plus or minus 4i over 10. But we always want to simplify our roots. Well, we can divide all these by 2. So let's divide these all by 2 and rewrite a simplified answer. So the roots are 1 plus or minus 2i over 5. And again, even though this looks like one root, it actually is two roots. One of the roots is 1 plus 2i over 5. And then the second root would be 1 minus 2i over 5. So, as we saw, when you solve a quadratic equation, you're always going to find two roots. Because the degree of that equation is degree 2. The degree tells you how many roots that equation has. You don't know whether the roots are going to be real numbers or complex numbers. Okay? On the first two examples, the roots were real numbers. On example C, the roots were complex numbers or imaginary numbers. Alright, so let's take what we have learned from first semester, what I just went over, and what we learned yesterday. I went 2 days ago. 2 days ago, we learned how to factor the sum and difference of cubes. So look at this example. It says solve the following cubic equation. Find all the roots. Well, you should recognize this. 8x cubed minus 125. That's a difference of cubes. So remember, we have a pattern. When you have a cube minus another perfect cube, that can be factored to the following. There's a pattern. You got your A, you got your B, and then we got A squared, and then to get the middle term, you take A times B, and then to get the last term, you get B squared. Then we remember the word SOAP to help us figure out our signs. The S in SOAP stands for the same. So since this is a minus sign, we're going to have a minus sign here. The O in SOAP stands for the opposite. We have minus sign, so we got a plus sign. And the AP means always positive. So let's look at 8x cubed minus 125. Let's rewrite 8x cubed as a perfect square. A perfect cube. That's 2x to the third power. And 125 is 5 to the third power. So 2x is my A value, and 5 is my B value. So I can factor this. So A is 2x. I put 2x in place of A. And then to get A squared, I take 2x times 2x, which is 4x squared. Alright? Let's do a B. B is 5. So put 5 here. And then we're going to get B squared. 5 squared is 25. Then we need to get our middle term. Well, to get the middle term, you multiply A times B. So let's multiply these together. 2x times 5, 10x. And then let's put our signs in. Remember, we can use SOAP to help us remember our signs. It's the same sign that your original thing that you had. You go factor, so minus sign. Opposite, always positive. So now we have the left-hand side factor. So now what we can do is, like we did first semester, what we did on the first 3 examples. Once you have it factored, you take each of the factors and set them equal to 0. Alright? So now we can find the roots. So over here, we would add 5 to both sides. We get 2x equals 5, and then divide by 2. So x is equal to 5 halves. So that's one of the roots. This is a cubic equation, so this has a degree of 3. So we're going to have 3 roots. So we're going to find 2 more. Well, the other 2 roots are going to come from this equation. Because what type of equation is this? It's a quadratic equation. So it has 2 roots. Just to save you some time, I'm going to go ahead and let you know, when you're doing these cubic ones, your trinomial one, your quadratic trinomial one, it's not going to be able to be factored. So you're going to have to use the quadratic formula, like we did on example C. So we got our A, our B, and C value. So the opposite of B, so negative 10 plus or minus B squared. So 10 squared is 100 minus 4 times A, which is 4, times C, which is 25. And that's all over 2 times X, so 2 times 4. So let's reduce this. This will be negative 10 plus or minus 2 times 4 is 8. Let's figure out what's under the square root. Well, 100 is just 100. So I'm going to have to take, let's do this. Let's do 4 times 25. That's 100. Times 4 is 400. So under the square root, we got 100 minus 400, which is negative 300. So our other 2 roots are going to be complex roots or imaginary roots. So we need to simplify our radical. We can pull out the square root of negative 1. And now I got to focus on 300. 300 is not a perfect square. So I got to find the largest perfect square that divides 300, which is 100. So I can break this down to the square root of negative 1 times the square root of 100 times the square root of 3. If you take negative 1 times 100 times 3, you get negative 300. So what we have now is negative 10 plus or minus. The square root of 100 is 10. The square root of negative 1 is I. Radical 3 over 8. So there are our last 2 roots. But again, make sure they're simplified. We can divide out of these by 2. We can divide everything by 2. So, the cubic equation I just solved has 3 roots. The first root is 5 halves. Okay, that's a rational root. Alright. And then the other 2 roots are, here's one of the other 2 roots. Negative 5 plus 5i radical 3 over 4. And then the third root is negative 5 minus 5i radical 3. These 2 roots are complex roots. Or imaginary roots. That's what we're going to be doing today. We're going to be solving cubic equations. And I might throw in some ones from first semester as well, because you need to know how to solve those as well.